What does it take to challenge Apple's $3 trillion empire? Apparently, $6.5 billion and a legend. When OpenAI announced it was acquiring IO, the secretive hardware startup from Apple's iconic designer, Jony Ive, it was more than just a headline. It was a declaration, a bet that the man who designed the iPhone could now help build the device that might one day replace it. The stated goal? To ship 100 million AI companions. But here's the real story. That $6.5 billion deal, as massive as it sounds, is dwarfed by the sheer scale of capital being deployed across the entire AI ecosystem. A far larger story is unfolding in the foundational infrastructure that powers this revolution. OpenAI itself is planning a data center codenamed Stargate with a price tag of up to $500 billion. And analysts at Bank of America predict total AI capex spending to reach $432 billion next year. The scale of the spending is redefining the economics of technology, and it raises the single most important question of this entire era. In a technological race of this magnitude, where is the value truly being captured? Is it with the high-profile labs creating the models? The chip designers who forge the silicon? The owners of the data that fuels it all? Or the companies integrating AI into the applications that shape our economy? The answer isn't simple, because this isn't one single race. It's a battle being fought across 5 distinct layers of a value stack. To understand who will win the future, you have to understand the battlefield, from the brutal physics of energy and silicon at the foundation to the applications that will transform our world at the top. This is the story of the AI value stack, and that story begins at the foundation. Let's unpack this. Before any AI can write a line of code or answer a single question, it must first obey the laws of physics. And the first law of the AI revolution is this: intelligence consumes power. A lot of it. The AI dream is built on a very real-world foundation of steel, concrete, and electricity. This is the infrastructure layer, the non-negotiable, capital-intensive bedrock of the entire stack. And right now, it's facing 3 critical bottlenecks. The first is land and construction. Hyperscalers like Amazon and Oracle are in a global land grab because they are the new landlords of the digital world. The insatiable demand for AI compute from their enterprise customers, from startups, and from their own internal labs forces them to build capacity at a frantic pace. If they can't provide the servers, their customers will go to a rival who can. We've seen this with the Stargate project in Texas, a facility so large it requires its own on-site gas power plant just to function. These aren't just server rooms, they are city-scale industrial projects where construction timelines have become a key competitive advantage. The second, and perhaps most urgent bottleneck, is energy. According to the International Energy Agency, data centers worldwide could consume as much electricity as Japan by 2030, with AI being the single biggest driver of that demand. This isn't a problem that can be solved with a few more solar panels. We are seeing a quiet but frantic push into industrial-scale power solutions. In Washington, the Trump administration is fast-tracking permits for new energy projects, and in boardrooms, companies are having serious conversations about a once unthinkable power source for their data centers: nuclear energy. The sheer power demand of AI is forcing the tech industry to become one of the world's most sophisticated energy players, practically overnight. And finally, there are the picks and shovels of this digital gold rush: the chips. For now, this market is a story of one company, Nvidia. Their 92% market share in AI data center chips isn't an accident. It's the result of a brilliant 2-decade strategy. Their dominance isn't just about having the fastest chip, it's about CUDA, a proprietary software ecosystem that has become the native language for the world's best AI researchers. And it's about their integrated hardware, like NVLink, which allows thousands of their chips to function as a single cohesive brain. This full-stack solution is a fortress that is incredibly difficult for rivals to replicate, making Nvidia a strategic choke point for the entire industry. It's a position of power that allows them to command gross margins estimated to be as high as 80% on their data center chips. And in the current AI arms race, their biggest customers are willing to pay it. Why? Because in a frantic race to build out massive computing capacity, the cost of being slow is seen as far greater than the cost of Nvidia's premium. This is why the world's most powerful companies line up to pay the Nvidia Tax. This, in essence, is the infrastructure layer. It is the physical manifestation of the abstract demand for AI. Every dollar of anticipated software revenue requires $100 of prior investment in this brutal, tangible reality of hardware and energy. Those who control these physical foundations hold immense power over everyone building on top of them. But the most powerful factory in the world is useless without raw materials to process. And in the AI economy, that new raw material is data, and the battle to control it is just as fierce. The AI factories of the infrastructure layer are hungry. They consume vast amounts of electricity and require billions in capital. But their most critical input is something far more abstract: data. If compute is the engine of AI, then data is its fuel. And just like the oil booms of the 20th century, the world is now realizing that the source of this new fuel is finite, legally complex, and intensely fought over. This is the data layer, and it's where the digital and legal battle for AI's future is being waged. For years, AI labs treated the open internet as a free, all-you-can-eat buffet. They scraped trillions of words and images from blogs, news sites, social media, and art forums to train their models. But that era is over. The core problem is what creators call a parasitic relationship. AI models are trained on human work and then used to generate content that directly competes with and devalues that same human work. This has ignited a legal firestorm. We're seeing this play out in real time with the New York Times' landmark lawsuit against OpenAI and Microsoft. It's a case that goes beyond simple copyright. It's a battle to determine if creative work is a public resource to be scraped or private property to be licensed. The outcome of this, and dozens of similar lawsuits, will fundamentally redefine the economics of data. This legal risk has created an entirely new market for a different kind of company: the data refineries. The most prominent example is Scale AI. Their business isn't building the flashiest models, but doing the grueling, essential work of sourcing, cleaning, and labeling massive data sets to make them AI ready. They are the logistical backbone of the data supply chain, and the strategic value of this position is immense. It's why Meta just orchestrated a complex $14.3 billion deal to secure a 49% stake in the company and hire its CEO. Big tech isn't just buying models. They're trying to vertically integrate and control the data pipelines that feed them. But what happens when you run out of high-quality human data, or when it becomes too expensive or legally risky to acquire? You manufacture your own. This is the final frontier of the data layer: synthetic data. AI models are now being used to generate vast quantities of artificial text and images to train their successors. It's a clever workaround, but it comes with its own risks. Researchers have warned that models trained on their own outputs can begin to fold in on themselves, developing strange digital defects in a process some call model collapse. The fight for data reveals a core tension in the AI revolution. The technology requires a constant stream of high-quality information, but the very act of acquiring it is becoming one of the industry's biggest legal and ethical challenges. Control the fuel, and you control the engine. But first, you have to figure out how to get it out of the ground without blowing yourself up. Once the data is mined and refined, it's handed over to the alchemists. This is the model layer, the domain of companies like OpenAI, Google's DeepMind, and Anthropic. These are the names that dominate the headlines. Their mission is to take the raw material of data and, through the mysterious and computationally brutal process of training, transmute it into pure intelligence. They are the celebrity prospectors of the AI gold rush, promising to deliver artificial general intelligence, or AGI, the digital equivalent of the Philosopher's Stone. To achieve this, they are waging a relentless war for human capital. This isn't just hiring. It's a strategic battle for a few dozen to a few hundred key researchers on the planet. Meta is offering seven-figure signing bonuses and compensation packages purportedly exceeding $100 million. It's a market where talent is so scarce that the top minds, like Noam Brown or the founders of Inflection AI, are courted directly by CEOs like Sergey Brin and Satya Nadella. This talent war isn't a sideshow. It's a leading indicator of where the industry believes the core intellectual property resides. It's a bet that the magic formula for AGI exists not in a vault, but in the minds of a few key people. But here is the central paradox of the model layer. For all the talk of building an impenetrable moat of intelligence, their position is surprisingly fragile. The biggest threat isn't a rival's breakthrough. It's the risk of commoditization. The alchemist's formula is proving to be less secret than anyone imagined. This was the core lesson from the DeepSeek moment. In January 2025, a relatively unknown Chinese startup released a model that achieved top-tier performance at a fraction of the cost using older, less powerful chips. It sent a shockwave through the industry, proving that a massive budget and the latest hardware were no guarantee of a permanent lead. This dynamic, the constant threat of commoditization, is one of the underreported stories in AI, and it's a theme we break down constantly in our newsletter, ARPU. The simple truth is that for all the talk of moats, the only real defense these labs have is access to capital, which they use to run a brutal, high-speed treadmill of innovation. Labs are now on a punishing release cycle, pushing out new models like GPT 4.1 and Gemini 2.5 in a constant effort to reclaim the top spot. But each leap forward seems to be matched just months later by a competitor. The alchemists may be the public face of the revolution, but their magic is useless if it's trapped in the lab. For their intelligence to have any value, it needs a gateway to the real world, a way to reach you. That brings us to the next battleground in the AI stack, the interface layer. This is the hardware and software that acts as the final gateway between a user and the vast intelligence of the models. It's the screen you touch, the voice you speak to, the device you carry in your pocket. In the AI economy, controlling this final gateway might be the most powerful position of all, and it has ignited a new war between the industry's titans. On one side, you have the incumbents, Apple and Google. They currently own the two dominant platforms in the world, iOS and Android. With over 2 billion active devices, Apple has an unparalleled distribution channel directly to the consumer. But the saga of Siri's delayed AI makeover and Apple's reliance on partnerships with OpenAI is a story of a giant struggling to adapt. Apple risks being disrupted if it can't give customers a compelling AI experience on the device they already own. Their recent move to finally open up their AI models to third-party developers is a classic Apple playbook move, leveraging their massive platform to catch up. But it's a defensive one. This sluggishness from the incumbents has created the opening for a direct assault on the hardware front. The most audacious challenge is the $6.5 billion deal between OpenAI and Johnny Ive. This is a gambit to create an entirely new hardware category, the AI companion. Their stated goal of shipping 100 million screen-free, contextually aware devices is a direct shot at the iPhone's dominance. They are betting that the very concept of interacting with AI through a glass slab is a legacy idea, and that a new form factor is needed to unlock AI's true potential. This isn't a peripheral skirmish, it's a fundamental fight for the future of personal computing. Meta is pursuing a similar strategy with its Ray-Ban smart glasses, integrating its Llama models to create a hands-free AI assistant. Google, meanwhile, is hedging its bets, partnering with Samsung and Warby Parker on its own AI-powered glasses. What all these challengers understand is a core strategic principle. If you own the device, you control the user experience. You decide which AI is the default, how it integrates with a person's life, and ultimately, who captures the value from those interactions. But this battle isn't just being fought with new hardware. A third front has just opened up, aimed squarely at the most dominant piece of software in the world, the web browser. Enter Perplexity. Backed by heavyweights like Nvidia and Jeff Bezos, the startup has launched Comet, an AI-powered browser designed as a direct challenger to Google Chrome. Their strategy isn't to replace your phone, but to replace the main window through which you access the internet on it. Perplexity aims to transform the browser from a simple navigator into an agentic AI that can think and act on a user's behalf. Instead of just searching, its built-in assistant can compare products, summarize content, and even book meetings within a single conversational interface. Perplexity is launching a strike at the heart of Google's empire, betting that the most valuable interface isn't the device in your pocket, but the software you use to navigate your digital life. The battle for the interface layer is a 4D chess match with multiple fronts. Do you try to build a better AI experience on the 2 billion phones that already exist? Do you bet that AI is a wave so powerful it will demand a completely new kind of device? Or, like Perplexity, do you attack the software gateway that billions of people already use every single day? The winner of this fight may not be the company with the smartest model, but the one that builds the most seamless, powerful, and indispensable gateway to that intelligence. At the very top of the stack, we move from potential to profit. This is the application layer. If infrastructure is the land, data is the oil, models are the alchemy, and hardware is the gateway, then this layer is the boomtown, the sprawling, vibrant economy built on top of it all. It's where the abstract power of AI is finally harnessed to solve real-world problems, automate workflows, and create tangible economic value. For many, this is the layer that will ultimately matter most. The first signs of this boomtown are emerging in the enterprise software market. Companies aren't just selling AI, they are selling AI-powered solutions. We see Salesforce acquiring Informatica for $8 billion to help customers roll out AI tools faster. We see Adobe raising its revenue forecast, helped by continued demand for its AI-powered software tools that generate images and video content. This is the boring but incredibly lucrative work of embedding AI into the core plumbing of the global economy. But it goes beyond just improving existing software. A new category of agentic AI is beginning to automate entire job functions. The accounting firm RSM found that deploying AI agents to autonomously run compliance reviews yielded gains of up to 80%. This is a paradigm shift. It's the difference between giving a worker a faster calculator and hiring a robotic accountant that works 24/7. It's why startups like Mechanize are being founded with the explicit goal of automating labor, and why companies like Hippocratic AI are deploying AI clinicians to handle patient check-ins. This is the ultimate promise of the AI stack, and it's where the trillions of dollars invested in the lower layers are expected to pay off. It's about moving from a world where AI is a novel curiosity to one where it's an economic utility, as essential and invisible as electricity. The companies that succeed at this application layer, whether they are incumbents reinventing themselves or new players building from scratch, are the ones who will translate the raw power of the models into the productivity gains that reshape entire industries. In the long run, these are often the businesses that last. So, after a journey through the 5 layers of the AI stack, we return to our central question. In a gold rush of this magnitude, who is really winning? The answer is becoming clear. The current narrative, fixated on the celebrity alchemists at the model layer, is missing the bigger picture. The true, durable power in the AI economy is consolidating at the two opposite ends of the value stack, the very bottom and the very top. At the bottom, you have the new titans of industry controlling the physical world, the companies that own the infrastructure, the chips from Nvidia, the data centers from the hyperscalers, and the energy grids that power them all. And the companies that own the data, the new oil that fuels every model. These are moats built on physics, capital, and law, and they are incredibly difficult to drain. They are the landlords of the digital age, and everyone else is just renting. And at the very top, you have the companies building the real-world economy, the ones focused on the application layer, who are taking this raw intelligence and turning it into measurable profit and productivity. These are the companies solving specific, tangible problems for businesses and consumers. While the model makers are locked in a costly and volatile arms race, the application builders are quietly integrating AI into the fabric of our lives, creating sticky, indispensable services. The layers in the middle, the models and the interface, are where the greatest uncertainty lies. They are the most glamorous and receive the most attention, but they are also the most vulnerable. They are being squeezed from below by their dependence on infrastructure and from above by the need to prove their value through applications, all while facing the constant threat of commoditization and disruption. This 5-layer stack is the strategic map for the next decade of technology. As the AI revolution continues to unfold, tracking the flow of capital, talent, and value across these layers is the key to understanding who is truly winning. And to do that, you don't just follow the headlines, you ask the right questions. Here's the framework. For any major AI development, ask yourself the infrastructure question. Is this increasing or decreasing the dependency on a single hardware or energy provider? The data question. Does this generate a new proprietary stream of data that no one else has? Or is it just reprocessing the same public data everyone is already fighting over? The model question. Is this a true performance leap or just an incremental move in a commoditizing race? The interface question. Does this reinforce the dominance of existing platforms like the smartphone, or does it create a path for a new one? And finally, the application question. How will this technology actually be used to make a business more profitable or a product more useful? Thinking in terms of these 5 layers is the core of our analysis here, and it's how we cut through the noise to find the real signal. It's a complex, multi-front war, and we'll be tracking every move. If you want to continue to get this kind of strategic breakdown of the business of tech, you'll find the link to our newsletter, ARPU, right at the top of the description. Thanks for watching.